Okay, so this is Unit 1, 1.8, and we're going to look now at proving triangles similar, and we're going to do 2 days on this, and then we'll finish up the unit. So when we look at how we're going through our unit here, we've done 2 days kind of using scale factors. So this is really where we were applying the idea of we know we have similar figures, so how can we use it? And we can use that to find missing sides, we can use that to set up proportions and solve, and things like that. So now, what if I'm giving us 2 triangles? And so say they look like this. How do I know if they're similar? So by definition, we have 2 things that we're checking for. So we needed angles to be congruent, and we need sides to be proportional. And so one of the things that we're going to see is that we don't actually have to show both of these. In our last units in Integrated 1, we talked about congruent figures, and we had side, 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 angle, angle, and angle, angle, side as all ways to prove triangles congruent. Just like that, we're going to look at different combinations that actually guarantee now similar figures. And so the first one that we're going to look at is in order to determine if these 2 are similar triangles, we're going to say our first rule here is called angle, 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 triangle similarity. And sometimes people will just do angle, angle because the rule says if at least 2 corresponding angles are congruent, so we want congruent angles, then the triangles must be similar. So this is something that is always true. So on this one, we have angle A is congruent to angle D because we have 75 here and we have 75 here, so I'm marking my picture. Then we have angle C congruent to angle F. So I have this angle 31 degrees matches up to this angle 31 degrees. Even though we don't know angle B and angle E, because we know that the angles in a triangle are limited to 180 degrees, if I took 180 and on this triangle subtracted the 75 and subtracted 31 and did the same thing on this one, this would give me the same number. And again, it doesn't even matter what it is necessarily because once I already have 2, I know that because we have that limit on the angle, 180 degrees, that we're going to get angle, 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 and then we use our similarity symbol. This tells me those 2 triangles are similar. So because I have angle, angle, angle similarity, I know that triangle BAC is similar to triangle, okay, so if I labeled that one BAC, I'm going to say triangle EDF. And so as we're looking at this, this is one way to show and guarantee that I have similar triangles because of the congruent angles. All right, so let's apply some previous knowledge here. And so I have some recall ideas that I want us to go through that we're going to be applying into our similarity problems. So we've talked about vertical angles before where we have angles that are across from each other like 1 and 2. And what we want to get from that is that we know they're congruent. And so if I had 2 triangles set up like this, and I didn't know their measurements, vertical angles, always congruent. So that's something that we can add to the picture. Okay, the next one is the reflexive property. So maybe we have something like this, okay, where we have 2 triangles, and I have one, and I'll even make this other one red. So I have my red triangle, and then I have my purple triangle here. Okay, man, I need to practice my tracing. All right, so if I have these 2 triangles, notice that they share this angle at the top. So even though it's technically part of the red triangle here and part of the purple triangle here, it's the same angle. It's part of the same object. And so if this was labeled angle A, we know that angle A would have to be congruent to itself. This is the reflexive property. And so this is something that also we can add because it's always true. Everything's congruent to itself. So if I made a duplicate of myself, I'm the exact same as that clone. This is reflexive. If I look in a mirror and I saw my sister or my brother or my students, that would freak me out because my reflection should be me. All right, so these are two things that we want to be able to add to our pictures if we have them. The next two are looking at recalling stuff from integrated 1 again, where we have parallel lines. And so if I have a set of parallel lines, and I might not even add a transversal here. So if I have parallel lines here, even if they don't look parallel, that could just be my drawing here, I add a symbol to it that tells me these are parallel. And so the symbol for parallel might not be given written out, it might be given in the picture. So that symbol tells us that these lines will never intersect. And what that helps us with here is that we're going to get angle pair relationships from parallel lines. Okay, so if I have parallel lines here, I know that if I have, parallel lines, so I'm going to draw in my lines here. And if I cut it by a transversal, we had angle relationships. So if I put my parallel line information here, there were several angle pairs. We had corresponding angles, alternate interior angles, alternate exterior angles, and we had same side interior angles. So of these 4 in this unit, we might use corresponding, we might use alternate interior, but if we're looking at triangles, typically we're not going to use alternate exterior angles or same side interior because those aren't congruent. These are the ones that add up to 180. So vertical angles, congruent relationship. Reflexive, congruent relationship. If I have parallel lines, it's getting me an angle pair relationship. Typically corresponding, where they might be in the same position, or alternate interior, where maybe I have some sort of twist going on inside my triangles that might be getting me congruent angles that way. And so we're going to see those as we kind of move on looking at similarity here. So if we look at the directions in this section, it says, determine whether the triangles are similar by angle, angle, angle similarity. So we're looking for 1, 2, and really 2 leads us to the third congruent set of angles. If yes, write a similarity statement. So that would be triangle blank is similar to triangle blank. The first 2 right off the bat, do you see this symbol here? It's indicating we have parallel lines. So as we start kind of looking for these, angle, 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 we need congruent angles. So my first thing that I see here are vertical angles. So if I put angle 1 and angle 2 here, that relationship gets me one of my angles. Parallel lines here, cut by a transversal, notice that I'm going to get alternate. I'm going to put 2 here. Interior angles. These 2 are alternating on the inside of those 2 parallel lines. One's here and, one's here, one's down here as we look at those 2 angles. Here's C, here's G, if I erased the extra pieces going out. All right, so that gives me another angle pair relationship. And again, whatever those measures are, once I have 2, that third sets in. So this is angle, angle, angle similarity. Because once I have 2, this third one will follow, which tells me that triangle CDE has to be similar to triangle. Okay, C goes with G, D goes with F, and E, that's our vertical angle there, goes with E as well. So I was able to determine angle, 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 and I've written my similarity statement. This is my answer. Looking at number 2, Okay, this is where I have that two triangles here where they're overlapping. I have QPL here and MLN here. Notice that L is part of both of those triangles. This is that reflexive angle that gets us a congruent pair because angle L is part of both the smaller and the larger triangle. Also notice that again, now we have these parallel line markings. Where we got alternate interior from the parallel here, now we're going to get corresponding. This angle is in the same position as this angle. Where now if I had something hit here, we have M that's up here, and we have Q that's up here if we were looking at erasing the extra pieces here. They're in the same position. Do you see M and Q and the similar idea here? And so as we look at that, that gives us another angle congruence, which means the third one has to follow no matter what, giving us again angle, angle, angle similarity. So now we can label our similarity statement saying triangle QLP. And again, doesn't matter how we name the first one, matches up to MLN. Triangle MLN. I've verified that it was angle, angle, angle similarity, and I've given my similarity statement. On 3 and 4, we're doing the same thing. We're looking for that angle congruence, angle congruence, angle congruence to make them similar. So if I look at number 3, I have right angle here, that gives me one angle congruence. I know 90 degrees on Y is the same 90 degrees that we have on C. This time I don't have any parallel markings to get me alternate interior or corresponding. I don't have reflexive and I don't have vertical angles. But they did give me 39 here and 51 here, which is not a match. But what I need to do is figure out what S is, because maybe that 51 matches S here. So I'm going to take 180 and subtract the 90 and subtract the 39 to see what this angle measurement is. So if I take 180, and I'm going to put in my calculator here, minus 90 minus 39, I get 51. Okay, so even though E was not matched to the given W here, this 51 degrees is a match to the 51 degrees here, which means I have another angle congruent relationship. The 39 here will be the match to H. So if I did this again and did 180 minus 51 minus 90 from this triangle, I would get that 39 degrees. Because I already have two matches, the third has to match. This is another angle, angle, angle similarity, giving us similar triangles. So triangle SYE is similar to triangle. So S is the 51, so I'll go with W. Y is the 90, so C and H. So this is more collecting of parts. I want the angle, the angle, the angle. Congruent pair, congruent pair, congruent pair. Guarantees I have similar. Let's check on number 4. So on number 4, they give us already angle P's congruent angle Z. That's given. That's what they're marking in the picture. So right away, we already know we have one angle. We don't have any parallel markings on anything, so we can't use corresponding or alternate interior. But what we do have here is vertical. And again, that's where we can always add those angles in and know that vertical angles are congruent. This gives us a second congruent pair of angles. If I have two, it doesn't matter what these are, they will have to match, giving me that third one. So I can label my triangle PQX is similar to triangle P. Okay, we'll go with Z. And again, I have to be careful on my order here. And then I have YX will follow to match everything up with the corresponding parts. So we've had 4 in a row that we were able to use in different ways, angle, angle, angle similarity. On number 5, okay, we have triangle LMN, so the big triangle here, and then we have our smaller triangle CBN here. I guess CBN if I went the other way. All right, N is part of both of those triangles, so I'm going to mark it. That's a reflexive angle. That gives us that congruent angle pair because it's the same on both of them. Angle in is part of both of those triangles. All right, so now we're missing angle B because 25 does not match 91. That's not an angle congruent. But maybe this is 25 as well. So I'm going to check doing 180 minus 91 minus 67 and see if we get the 25 degrees that I want it to match with. So 180 minus 91, putting it in my calculator, minus 67, I get 22. They're not a match. And as soon as I don't have a match, I'm done. I only have one angle pair. That's not enough information. So these are not similar. Because this didn't match the 25 that was here, these are not similar objects. They have to be the exact same, congruent, 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 in order to guarantee that similarity. So from this one not matching this one, not similar. I don't have to write anything else. I verified that they're not similar objects here. Okay, moving on to 6, we're going to do a similar idea. We don't have the same angle because they're not connected or overlapping. We have a 68 for angle A, matching a 68 for angle F, giving us one pair of congruent angles. But again, these two don't match. So maybe 54 matches E. So I'm going to find it by, again, just focusing on this triangle, minus 68, minus 63. So I'm going to take 180, minus 68, minus 63. And I'm hoping it matches that 54. But what I got was 49. If these two don't match and these two don't match, this is, again, not similar. So even if they look similar, our eyes can't verify, a difference between 4 or 5 degrees when they're small like this. I mean, if I drew a 90-degree angle, how do I know that's exactly 90 if I don't measure it? We put a box in it. But how do I know that's 30 degrees and not 31 degrees? Without measuring it, I have to trust the measures that are given. So when we have the visual that kind of looks like, ooh, maybe that is 54 degrees, we have to make sure we do the math to verify without saying, oh, I bet that is 54. We want to make sure. So we double check using the triangle sum here. Okay, as we kind of finish here, before we move on, this is the first one, but there are 3 ways that we're going to use to prove similarity. So the first one, angle, 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 all about the angles being congruent. The next part is going to be side, 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 triangle similarity. This is our second way of proving that triangles are similar. And so what we need when we're doing similar objects, if we need all pairs of corresponding sides, and this time they're not going to be congruent because 3 isn't congruent to 6, 4 isn't congruent to 8. We're not trying to make these congruent objects. We want them to be similar objects. And the relationship that sides have is proportional. So we need proportional side, proportional side, proportional side, meaning if I put smallest to biggest in order on the first one, and then on the other triangle, put smallest to biggest on the second one. So this is my first triangle. This is my second triangle. And I went smallest to biggest. Okay. These should all be equal if the triangles are similar. So if we simplify each one of these, 3 divided by 6, 0.5, 4 divided by 8, 0.5, 5 divided by 10, 0.5. If all of those are true, that tells me the triangles are similar. So this is our side, side, side. Proportional gives us the similar triangles. So I know because all of these are equal, the 0.5, 0.5, 0.5, I know that QPR is similar to triangle TSU. So we want to kind of keep that in mind as we're looking at the difference between congruent angles, where we're looking for matches, identical, proportional sides. We have to set up those ratios and compare them. All right, let's look at an example. Determine whether the triangles are similar by side, side, side similarity. So now we're looking for proportion. If yes, write the similarity statement. All right, so we have all three sides given here. We have all three sides given here. So I can check side, side, side. So I'm going to put, this is going to be my first triangle, this is going to be my second, and I just go smallest to biggest. So 9, 13.5, and 20.25. And I'm going to compare it by dividing to this triangle here. And again, I'm going to go smallest to biggest. So I have 14, I have 21, and I have 31.5. And by going smallest to biggest, it just makes sure that I'm lining up the corresponding parts. If I tried to do 9 with the 31.5 and 20.5 with the 14, there's no way that those would be the proportional. All right, so once I'm checking this, I want to see, are these equal? So I'm going to just divide in my calculator. 9 divided by 14, and I get a decimal, 0.6429. And then I'm going to check 13.5 divided by 21. And again, I get, okay, so 0.6429. If these don't match, we're done. We know they're not similar. But if I have a match, I kind of get excited, and then we check the last one, and I get the same 0.6429. So I rounded this a little bit, but those decimals looking at my calculator are the exact same. So because this is true, I know I have side, side, side similarity. Triangle, I'm going to name the first one NKR, is similar to triangle. Okay, oh boy, okay, so now we don't have the angle markings, is in between the small and the medium. So small and medium is E. K is between the small and the big, so that's D, and then S. So how are those triangles similar? Side, side, side similarity to get our similarity statement. One of the things that people sometimes do is if we're missing a side or something, we try to make them add up to 180. Kind of keep in mind that our angles add up to 180. We've switched gears. This is the only way that we can check sides. On number 2, okay, so we have this smaller triangle here, so I'm going to write, again, in order, smallest to biggest, their sides. So I have 15, 20, and 30. And I want to compare to the corresponding sides of the large triangle. Okay, so this large triangle, I need to make sure that I'm adding those two together, that this entire length of 28 is that piece. This entire side of 6 plus 15 is 21, and 42 is given. So I want to make sure that I'm lining up those pieces and adding those together to make sure I have the total side length. All right, so again, I'm going to check the decimal just by dividing. 15 divided by 21 in my calculator, 0.714. 20 divided by 28 on the second one. Okay, good, I'm on a roll, 0.714. 30 divided by 42, 0.714. This is true, so now I have side, side, side similarity, because each of these are proportional, telling me that triangle, I'm going to name the small one WXV, is similar to triangle WYU. So because we have proportional sides there, we guarantee similar objects, similar triangles here. All right, on number 3. Okay, so I'm looking at this big one, and I'm going to go smallest to biggest. So I have 5, 12, and 16, and compare it to the other triangle. Smallest to biggest, I have 4, 7, and 10, and I'm going to check to see if this is equal. 5 divided by 4, 1.25. 12 divided by 7, I get 1.71. As soon as these are not equal, we are stopping right there. These are not similar. Even if we have a match here, which I don't think we do, 1.6, I mean, none of these are the same. These are not similar objects. So we can't use side, side, side to guarantee similarity, and we don't know anything about the angles. So we wouldn't be able to verify that these are similar. They're not similar objects. On number 4, okay, so I'm going to look at this smaller triangle and go in order, 5, 12, 15, and compare it to proportional on the other one. Okay, small, so it would be 18, 43.2, and 54. Going in order is important. We want to make sure that we're lining up those corresponding parts. So in my calculator, I'm checking the division. So I have 0.2777777. 12 divided by 43.2. I have the same 0.2777777. And 15 divided by 54 is also that 0.27777, which is a true statement, telling me we do have side, side, side similarity. All the sides are proportional. This tells me that triangle, I'm going to name this one APR, is similar to triangle. Okay, A, again, looks like it goes with T because it's between small and big, or I'm sorry, medium and big. There's T. P is down here, there's Y, and R matches up to itself. All right, so we do have our side, side, side similarity for this picture. And on the last one here, okay, we're looking at triangle, the big one, DEA, and then the smaller one, BCA here. So I'm going to look at the smaller one where I have the 6, 8, and 9 and line that up. 6, 8, and 9. And set up the division to see if these are equal. Okay, so I have the 24, I have the 16. I need to add these together to get to the 20 for this side. So now I have 16, 20, and 24 as my sides of the large triangle DEA. In my calculator, I'm going to divide 6 divided by 16, 0.375, 8 divided by 20, 0.4. Immediately, not equal. So, my conclusion, these are not similar. I don't have side, side, side similarity there. All right, so for today, we looked at 2 different ways that we are showing that we have similar triangles. Angle, 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 and side, side, side. Let me know if you have any questions, and have a good day.